All right, so starting off, we're just going to learn about triangles today. You probably know quite a bit of this stuff, but we're going to review some of the stuff you learned from middle school just so you're ready to go. So starting off, a triangle is a polygon with 3 sides. Now you should know what a polygon is from middle school. Who can explain just briefly what a polygon is, Jack? Just give us a few little bullets or what you think it is. A shape with 3 or more sides. Good. What else do we know about polygons? There's a few things you could say. Abby, what do you think? What else has to be in place for something to be a polygon? Good. All the sides have to be connected. In other words, there's no open sides. Okay. What else? There's one more thing that I really want. What do we know about those sides? What do they have to be? They have to be. What? They have to be straight. They have to be straight sides. Okay. There's no curves. There's no curves in a polygon. Okay. So we have. So basically, if you take a triangle and you extend out the sides, you have kind of like this diagram right here, and you've kind of seen one of these before when we did transversals, right? If I cover this up, what do you see? And what if I cover this up? And if I cover this up? We have 2 lines in a transversal, right? Okay, so if you extend out the sides, you have something we call interior angles, which are kind of these pink shaded ones. And we have exterior angles, which are all of these angles out here on the outside, the exterior of the triangle. Okay? So, take a look here. You probably know these words. You might not remember what they mean, but you've seen them before. A scalene triangle has...
Zero.
No congruent sides. Scalene means all 3 sides are different.
Wait, and iso is 2 equal.
Isosceles. Now I want you to underline this. At least. At least is kind of weird for a definition. At least 2 congruent sides. Now, yes, the most common isosceles triangle that we know about has 2 congruent sides. But what does at least mean? 2 or more. What's the most number of sides we have in a triangle? 3. So if it has 3 congruent sides, we would call it equilateral. But an equilateral is also isosceles. So you might not have known that from middle school. We would consider an equilateral to be isosceles because it has at least 2 congruent sides. Now, does it work backwards? Does the converse of that statement work? No. Is an isosceles triangle an equilateral triangle? Not necessarily. It could be if they're all 3 sides are congruent, but not always. Okay. So this is how we classify by sides. Circle that. There's 3 ways that you can classify a triangle by its sides, and that's scalene, isosceles, and equilateral. Okay. The next thing we're going to classify by is angles. And how many different ways do we have to classify by angles? There's 4. So the first one, we call it an acute triangle. How many acute angles do you think there are? Yeah, all 3. So all 3 interior angles are less than 90 degrees. All 3 of them have to be. A right triangle has 1. Why not 2? Yeah, then the triangle wouldn't be closed anymore, right? If you have 2 right angles, then it's just either a rectangle or a square or a trapezoid or something else. So there's only 1 right angle. And we just learned this. When we have a right triangle, what are the 2 sides that form the right angle called? The legs. So put 2 L's there. And what is the side that connects the 2 legs? The hypotenuse. So that's good to know now. Because we're going to learn a lot about right triangles.
I was trying to beat everybody to see.
Okay, the next one. How many obtuse angles could fit in a triangle? Only one, kind of like a right angle, right? Because if you have one obtuse angle, and then you have another obtuse angle, is that going to be a triangle? No, it's either going to be a trapezoid or it could be an octagon if it kept going, or some other shape. So there's only room for one obtuse angle. An equiangular, what does that sound like? Equiangular. All three angles are congruent. They're all equal measures. So you can see there's arcs in all three angles. That means they're all congruent. Equiangular. Good. Here we go. Classify the three triangles by side. All right, Michael, what did you name the first triangle? Equilateral. What else could we call this? There's one other one, Sean? We'll find out later on that if it's equilateral, it is equiangular. But equiangular is by angles, right? We're only classifying by sides here. So there's one more side classification that would work. Skylar? Isosceles. Remember, if it has at least two congruent sides, it is also isosceles. So there's two answers there.
Wait, do you have to say both?
I would, yeah. Because there's two ways to classify that by sides. Yeah. That could be like a circle all that apply type question on the test, where you have to circle numerous answers. Boston, what's the only answer for the second one? Isosceles.
Is this gonna be our
Isosceles. It's not equilateral, right? Because all three sides aren't congruent. Maybe. And then the last one. Let's have Lauren. What did you call the last one? Scalene. Good. All three sides are different. All right, 30 seconds. All right, Caleb, what did you call the first one? Equiangular. That is correct. There is another answer for this one. Did anyone catch it? It would be acute. Good. How do you think he figured that out? First of all, let's think about how many degrees are in a triangle. Does anyone know that off the bat? 180. Good. 180. We're going to learn that. We haven't even learned that yet. But a triangle has 180 degrees on the interior. But all three angles are the same size. So take 180 and evenly divide it by 3, and what do you get? 60, which 60 degrees is less than 90. So in this case, all three angles are less than 90. So it is also acute. Good. Ashley, what did you get for the second one? Good. Obtuse. And that is the only answer. That's one obtuse angle. And Lily, last one? Right triangle. That is, once again, the only scenario that fits that triangle. So there's two triangles. This one here that had two answers, and this one here that had two answers. Okay, so you got to think about those. All right, I want you to, on your own, we're going to test your drawing capabilities. I want you to draw an isosceles right triangle and an obtuse scalene triangle. So you need to draw two triangles. See if you can create both of those scenarios on your own. Go. Any questions on these? All right. It says we need to classify triangle RST by its sides. Then determine if the triangle is right. So starting off, we need to find out how long each side is in order to classify it in a coordinate plane. So we do need to use the distance formula. Okay, so RT is right here. R to T. Now remember, the distance formula starts with x minus x. So what are my two x values at the end of R and T?
-3 and 3.
Yeah, -3 and 3. So I'll do -3 minus 3 squared. So we're just following this formula right here. If you've forgotten it, we've done it before. Plus, now if I started with -3, what y value do I have to start with? 3. So I have to do 3 minus -1
What?
squared. About what? Just following the formula. So now we get -3 minus 3. What does that come out to? No, there's not a ton of room here. So -3 minus 3 is -6. But when you square it, what is -6 times itself? Positive 36. Plus, and then 3 minus -1. 4 squared is 16. 36 plus 16 is? A high number. The square root of 52. Now, we don't need to take the time to do dates to prom and simplifying and all that because I don't care what the simplified answer is. All I care about is if it's the same as the others. I'm just trying to find out if the sides are the same or different. Okay? So now we go on to RS. So segment RS is from here to here. So we go -3 minus 5 squared. So -3 minus 5 squared plus 3 minus 2 squared is y minus y. When we simplify that, -3 minus 5 is what? Times itself? 64. Plus 3 minus 2 is 1. 1 squared is 1. So 64 plus 1 is the square root of 65. So once again, we don't need to simplify that. We don't need to do a factor tree because all I care is if it's the same or if it's different. And then the last one, ST, is from here to here. So x minus x would be 5 minus 3. And then y minus y would be 2 minus -1, which simplifies out to 5 minus 3 is 2, 2 squared is 4, plus, what's 2 minus -1? 3 squared is 9, 9 plus 4 is the square root of 13. All three sides were different, so we have proved that this is a scalene triangle. Now, one more thing, it asks us to find out if it's a right triangle. What does a right triangle have in it? 90-degree angle, which means the lines are perpendicular, and we just took a test over that. How do we know? On a graph, it's super easy if two lines are perpendicular. What do we know about their slopes? They're opposite reciprocals. Now, if you had to guess, which two lines look like they're a right angle? Maybe. RT and TS. So let's find the slope of these lines. So what is the rise over run of RT? -4 over 6. Which we're not leaving this class so I'm done with this problem, so you can pack up all you want. -4, 6 reduces to -2/3. Okay? But now we have to find the slope of segment TS. So what is the rise over run of TS? 3 over 2. Is -2/3 and 3/2 opposite reciprocals? Yes, so it is a right triangle.